All right, let's work on the second problem of the day, which is LeetCode number 152, Maximum Product Subarray. Given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return that product. Okay. And test cases are generated so that an answer will fit in a 32-bit integer. Okay. So first of all, sorting probably won't work because we need it to fit within a contiguous subarray, and we want to maintain the order. So sorting will probably not be valid here. What else could we do? Has to be a contiguous subsequence. So probably some sort of sliding window. Some sort of sliding window, but how do we optimize it further? Nums.size is less than or equal to 2 times 10 to the 4. So this probably indicates an O of n-ish algorithm. Let's see, if we use a sliding window pattern, well, let's see. Start with a window of size 1 at the base value. Of course, the corner case is that if nums dot size is equal to 1, return nums at 0, because that's the maximum product no matter what. It's because it's the only value within the subarray or within the array. And then we can say while the next value is greater than or greater than 0, add it to the product and increase the window. If the next value is 0, move the left side to index plus 1 and decrease move the index and shrink window to size 1. The idea is that if we hit a 0, anything that's to the left of it doesn't matter, because once we multiply that 0, it's done, right? And we can't possibly link the left and the right sides together because the 0 is in the middle. So if we have a next value of 0, immediately we move the left side to the index plus 1 position. And we shrink the windows back to size 1, and then we start to recalculate again. If the next value is less than 0, then we have a bit of a problem. This number could potentially product up to a larger value if and only if we have another number which is less than 0. So, in that case, do we want to grow the window as long as the value is not 0? Or do we want to avoid the negative numbers unless we know that there are multiple negative numbers within our sliding window? Of course, we could keep track of the negative numbers, Well, I guess naturally we do that already with our product, right? If we continue to grow our array, because if we have an odd number of even or an odd number of negative numbers, then we have a negative number, negative product. And if we have an even number, including 0, then we will have a positive magnitude product. So I think the main crux of this is just the introduction of negative numbers. More importantly, we're looking for the maximum product in both magnitude and direction, right? We want the maximum positive number. And if we have two negative numbers, then it's good. If we have one negative number, then it's bad. Or if we have an odd number, then it's bad. If we have an even number, then it's good. Maybe we just record the maximum. Let's see. If we had like a 2, 3, -2, 4, 2, how would we deal with this? We start here with 2, then we grow here to 6. We see this. We see this -2. We can choose to disregard it and continue on and grab this 8. But what if there was a -2 here? Then in this case, we know that there's another negative number after. So we should continue. But in this case, we know that we don't know that there's, in either case for this, if we're going purely left to right, we don't know that whether or not there exists another set of negative numbers. And of course, we don't know where the negative numbers are. So if we had something like 2 or -2, 3, 0, -4, 2, then of course there are two negative numbers within our array, but they're divided within different subarrays. So it doesn't matter. So how do we account for the negative numbers? Two times 10 to the 4, so it's an O of n solution. I don't know why, but it feels like no. I was gonna say that it feels like dynamic programming, but at the same time, I don't think that there are enough signals here to make it a dynamic programming problem. I think it's still sliding window. But there's got to be a smart way to jump around the negative numbers. The problem is that we sort of have a split at each negative number, where we can choose to either continue the sliding window or we can choose to reset the window. And there's no real way to know which one is correct. This is a difficult decision. Let me think. Let's start by closing the window. Because here we can choose, right? At each negative number, can choose to either extend the window or reset the window. Extending the window will only work to achieve the max if there exists another number less than 0 within the subarray. Resetting the window will only work if that is not the case. Right, so if there is an odd number, well, even if there are an odd number of, as long as there's more than one, there is only one number less than 0 within the subarray. Because if there are 3 negative numbers, we can take 2 of them. That's not a problem. So if there are 2 negative numbers, we can take them without problem. At least 2. If there's 1, then that's a problem. But if there are 2 and they're separated by 0, that's also a problem. It feels like a greedy approach, like the sliding window where we just keep on taking just doesn't work. But I'm not sure what the key is to actually getting this to work. Let me think about this some more. So the 0 is pretty obvious. The positive is pretty obvious. Is there any way that we could do this by potentially having 2 sliding windows, one going from the left to the right and the other going from the right to the left? If we have, let's say, a sliding window starting from right to left and left to right, then what does that do? Well, we know that if there is one negative number in each, then that's fine. But we kind of run into the same problem where if we have one subarray with a negative number and the other without, then does that mean that we can extend the other subarray until the value is non-negative, or until the value is negative, or it hits a 0? That might work. So 2 subarrays, one from the left to right and another from right to left. So for example, 2, 3, negative 2, 4, 2. We'll do 2, then 3. Then we hit negative 2. Then on the left side, we hit 2, then 4. Left to right. Right to left until we hit either a negative number or until the 2 windows meet. Right? And then all the while, they're just calculating the largest product. So we have 2 times 3, that's 6, times negative 2, that's negative 12. Then we start the right to left, which goes 2, and then 4, which is 8, which is larger than 6. But now once we hit 4, the next value is negative 2, which overlaps with the right side window. And then we end there. And we return 8. That seems to work. Okay, let's try 2, 3, negative 2, 4, 2. That goes 2, 3, negative 2. Then we go 2, 3, negative 2, 4, negative 2. This goes negative 2, then 4. Well, this goes negative 2. And stops there. Stops at a or after multiplying a negative number. And then this goes 4. So this is left to right. That's right to left. This is left to right appended. So we add 4 onto our list. And then we can say that if both are less than 0 when they meet, then we can append them together. And we know that since both of them are negative, that the product of both of them will be the largest number, no matter what, right? Because that's just magnitude, or positive magnitude, as long as we just get to the positive. So I think this makes sense. Let's see. Let's try the third case. 2, 3, 0, negative 4, 2. This goes negative 2. This is left to right. Then this goes 2, negative 4, right to left. Then this goes to 3, left to right. So max here is still, max is negative 2, then max is 2, then max is still 2. How do we get this 3 as the maximum, though? If number is greater than current max and number times current is less than 0? I mean, that could be one way to do it, but I'm not sure if that accounts for all cases. Right, so we have 2, negative 3, then we hit a 0, so we cross over to 4, and that's where we break. Stops once we reset the window to negative 4 after jumping the 0. It seems like an interesting approach. It might work. I'm just a little bit apprehensive about the cases. And let's see, if we have 2, if this runs into a second negative, like for example 2, negative 3, 2, 4, negative 2, then really what we want is do like that, right? So this hits negative 2, or 2, negative 3, then this hits negative 2, then this hits 2, or negative 2, and then 4, at least it should, because the number is already less than 0, we can take more negative numbers. So we had to check there. Before switching, not. I think this works. It's reasonably O of n because we're just scanning left to right until we meet. So I guess we could start coding. So we can say var left window left is equal to 0. Var left window right is 0. Var right window left is equal to num size minus 1, var right window right is equal to num size minus 1, while the left window right is less than the right window left. I know that's a mouthful. We can say var greatest product, or max product. We'll just call it max. Turn max. We can say while left window right is not, or is greater than 0. We can call this var left product, var right product. Started at 1. Left product plus or times equals nums at left window right. We can start it at num 0. So while the next number is greater than 0, then we add it. If left product plus 1 is less than 0, else if nums at left window right is equal to 0, then we say left window left is equal to 0, or is equal to left window right plus 1, left window right plus plus, right? So we're just skipping the left window right. We're just skipping one index ahead so that we don't multiply the 0. And then left product is equal to 1. I think we reset it too. If the window is less than 0, then we check if left product is less than 0. Otherwise, so if the left product is less than 0, then we can just say left product times equals nums plus left window right. So we just absorb the number if, or left product less than 0 and nums at left window right is less than 0. So we don't need this else case. We know that if this occurs, in this case, the value is less than 0, and we know that that product is greater than 0. In that case, if we are greater than 0 and the next number is less than 0, we'll do left product multiply equal nums plus plus left window right. So absorb that negative number. Or what we can do, if we make this an if statement, then we can move here and we can say if left product is greater than 0 or is greater than max, max is equal to left product. Then we want to apply pretty much the same thing to the right window. There's got to be a simpler way to accomplish this. This feels like way too convoluted. This feels way too convoluted for a medium problem too. You can multiply it in. What if we, rather than doing two, what if we create a list of products? So var left is 0, var right is 0, val previous or prefix product is equal to a mutable list of integers, while right is less than num size minus 1, or not num size minus 1, just num size. We can say var current product is equal to 1, num's at 0. If current product multiplied equals let me think. While right less than nums dot size and nums at right is greater than 0, current product multiply equals nums dot right plus plus. So this will add our current product and then increment it. So for 2, we will go 2, then 3, then we will hit -2, at which point we will stop here. If we do this current product correctly, because it starts at 1, then well, our nums right is greater than 0. So we multiply a current number and then we increment it. Then we can say, so now at this point, nums at right is either less than 0 or equal to 0. So we can say if nums at right is equal to 0, otherwise. So if it's equal to 0, then our job is pretty simple. left is equal to right, and then we just continue. Right, so the idea is that, or right plus 1, right plus plus. So we just skip that number, and then we can say our current product is equal to 1. So we reset our current product down to 1 again. And we don't need to save a prefix product. So this prefix product is exclusively for negative values. And we can even say like prefix product dot clear or something. Could probably actually not. We could probably actually even do away with the prefix product now that I think about it. We can solve that a little bit later. What we'll do is we'll do a so now this is less than 0. Hold on. Let's see. If this is less than 0, then we do if prefix product is not 0. So we have not encountered a 0. So the negative value is, actually, if we do this, else, contiguous, we have encountered a 0. We have either encountered a 0, or this is our first. It's fine. We start our prefix product as 1. This is a var now. The idea is that if it's 0, that means that we have we can keep it at -1, or we can keep it like this. We don't need this if statement. What we can do is that we can say so if we've encountered a negative number, so 2, 3, -2, what we want to do is pretty much the same thing as the 0. So we jump to the next value. However, we want to multiply this by our prefix product. Prefix, or we want to do right times, or current product times equals no, is equal to current product times nums at right. Then we can say that if current product is greater than max, max is equal to current product. if our prefix product here is less than 0, then we can continue and say current product times equals nums.write. Otherwise, we want to do that. All of that? All of that. So if our prefix product happens to be less than 0, so we go 2, 3, this -2, our prefix product is 1. It starts out as 1 as default. So then we set this as our prefix product as -12. As -12, and then we move on to the next one. And then we do 4, and then -2. At 4 and -2, well, we have 4 as our current product. Then we have -2 as our write product. If the prefix product is less than 0, then we had a previous prefix product that is less than 0, so we can multiply that into our current product and reset prefix product, right? So now our current product is going to be equal to this product, so -12 times 4, so -48, times also the nums.write, because that's less than 0, right? So the prefix product multiplied by this makes this positive, and therefore we can add it, and then we can reset our prefix product. If that isn't the case, so our prefix product is 1, which means that it has been reset before, then our current product, then we just set our prefix product to what we have currently and the negative number. So that would be this part. And then we reset to the next window, and then we reset to size 1. And yeah. It's a bit unwieldy to do this, but I think this will work. The idea is that, well, really, it's only in this situation where we actually have a potentially new max. So I'm just going to slap it into this if statement. And similarly, we can just have it here. So the idea is that we grow. So 2, we grab the 2, 3, we grab the 3. Then we hit the -2. Then we store into prefix product -12. So current product 6 times nums.write, which is -2. Then we set our left to our right plus 1, which is this. And we move our right as well. And then we continue on from there, and we set our current product back to 1. And then this number is less than or is greater than 0, so we do 4, and then 2, which is 8. And then we've hit the end, and well, 8 is greater than the 6 that we had before, so we return 8. In this case, we do the same thing, but here with 4, and then we hit -2. Well, we hit -2, but we don't want to grab it, right? So at this point, we know that prefix product here is -12 because we stored it before. So our current product is going to be 4 times -2, which is -8, times -12, which is positive 96. 8 times 12, yeah, 96. Positive 96, which is now a new max. And then we reset our prefix product because now we have a positive number. So this seems to work. And of course, we reset the prefix product and our current product to 1 after we hit a 0, because for our prefix product, well, we can't have a prefix product because it's 0, right? So we don't want to do that. So we just reset it to 1, and then our current product also to 1, and then we just grab the next one. So let's go ahead and run this. Looks like we had an out of bounds exception. If right is less than nums.size, and if right is less than nums size, actually we can do if right is less than nums.size, and then we move this in here. I think that should work. Okay, cool. Toss in some more edge cases. Cool, cool. Let's throw in a submit and let's see how we do. -2. Let's see. Let's see. We can do integer min value. If nums at right is equal, or if max is less than 0, max is equal to 0. Here we have a new product already. Here, well, we know that current product is positive and nums right is negative. That's why our prefix product is like so. So in that case, we can say that if, well, we know that current product will never be, in that case, if current product is greater than 0, then it'll get caught up. So there shouldn't be anything here. But we can also say here that if nums.size is equal to 0, then we just return nums at 0. And this should still take care of everything. Let's throw in a weird case like -2, -1. No, in that case it'll go prefix product here. Then here it'll go here, and then it'll multiply to get 2. So I think we're good for more test cases there. Or for most of the other test cases. What? Oh, equals 0. Whoops. I was like, what's going on? Let's see. -4, -3. Let's see, -4, -3. So for some reason, I'm multiplying everything, oddly enough. Let's see. -4 goes into prefix product, and that's current product times that, so that's just -4. Then 3 turns it into a nums right, so that would be a -3 times -3 times -4. That's 12. And we set the max at 12. Prefix product to 1. Then we take the -2. Interesting. Don't know why this is breaking. We can add some print lines to see what's breaking here. So current product, prefix, and why it's -12? Seems like it's multiplying on itself somewhere. So there should be 1 and -4, yep. Then 12 and 1, yep. Then 1 and -36. Was it just me forgetting to increment right there? Yeah, that looks like it was the case. This is why I'm not usually I'm just not comfortable really working with indices because it's so easy to get things wrong. Let's see what's going on there. -2 or 2, -5, -5, -2, -4, and 3. The answer is 24, which would be no. 8 times 3. Oh, it would be u. Interesting. It would be... So what I do is that I increment here. So I grab 2, this 5, so the prefix becomes -10. This -2 turns it into 20. Right, that becomes 20. But then this becomes... so the 20, and then we get 80, -80 in our prefix sum, but that doesn't matter. Interesting. Okay. Well, we're at way past the 30-minute mark, and we tried our best. This was a close solution, I think. Maybe not. We got kind of close to the solution. So I'm guessing that we just missed out on like maybe a couple of... Ultimately, I think it's just like we were close. I think we were on the right track. We just couldn't get quite to the answer we wanted. So let's take a look at the discussion tab, and then I'll be right back to explain the solution. Man, sometimes it's like with LeetCode, you just lead yourself down roads. You lead yourself down roads that are completely incorrect, and you just don't have someone there to say, stop it, you're being stupid. So I was wrong. There is no sliding window approach. And I think the crucial mistake that I made in misidentifying this problem as a sliding window was the assumption that a subarray lent towards a sliding window problem. While that is true that it does lend itself towards sliding window problems generally, it's not the case for this one because, well, we do not care about the locations in general of the subarray. We only care about the maximum product. So let's break down this answer further. So I'm not entirely sure where this answer kind of lies. It seems like it's dynamic programming feeling in terms of the solution and the approach. Though this is one of those problems where I can't really classify it really neatly into a box. We'll start with this. We really have 4 scenarios that we need to take care of. We either have a subarray that is positive and a new number that is positive, a subarray that is positive with a number that is negative, a subarray which is negative and a number which is positive, and a subarray which is negative and a number which is negative as well. So each of these scenarios could produce either a new maximum or a new minimum. So those are our 4 main scenarios, and then we have 2, I guess, sort of sub-scenarios, right? The sub-scenarios are cases in which we want to essentially reset the subarray. So this is when we have mismatching subarrays. The subarray and the subarray and the current number are mismatching in sign. But that mismatch, that new number, could potentially be a new maximum or a new minimum, and we might want to start from there. So those are the 4 things that we need to account for, the 4 main scenarios, the 2 sub-scenarios. So then we dive into our solution. So we start off by setting our min, max, and our product being the answer that we return, to the first value within the array. It's not really that important, but we just do so because that's where we start. Then we choose. For each of the numbers afterwards, we can either create a new maximum or we could create a new minimum. The 2 scenarios here is for the maximum are number times min, number times max. For numbers times min, min could be a number that is less than 0. And our number could be a value that is less than 0. If both cases are true, we have a potential for a new maximum. Likewise, if our number is greater than 0 and our maximum is greater than 0, then we have a potential new maximum there. Both of those situations constitute a situation where we are continuing our subarray. So 2 scenarios there. We also have a scenario where we potentially have a positive or a negative subarray and a very large magnitude positive value, in which case we probably want to keep the larger magnitude, and we want to essentially reset our subarray for our positives at that point. In the minimum case, we have a number multiplied by a minimum, so our next number multiplied by our minimum. In that case, we could have a potentially large number that's coming up, or really any positive number, right? Multiplied by our minimum could constitute another minimum. Likewise, if we have a number which is negative, and we have a really, really large positive number as our max, then that could produce a new minimum. And similarly to the maximum, if we had a number, a very positive subarray, and a very large magnitude negative number next, then we could consider that as a negative to consider for our next problem. So in both cases, handling the cases like this, we can cover essentially our entire solution set. Because a new minimum could potentially become a new maximum if the next number is negative, and a new maximum could potentially become a new negative or new minimum if the next number is negative. because that's how the products work. But likewise, we could also have a new maximum become an even greater maximum if we have two back-to-back positive numbers, or two back-to-back minimum numbers, or a subarray, right? And a similar situation for the minimums, we talked about that. So I'm not really sure what the lesson here is. And to be quite honest, I'm still not really familiar with the solution. I wish I could describe it more in detail, but I'm still trying to grapple with the intuition myself. But this problem seems to break down into specific cases. And then within those cases, we could sort of solve them and keep a record of our previous answers in a way that is reminiscent of dynamic programming. So this is essentially the solution that was given in various discussion posts. I've added a couple of comments, but not a lot. Just trying to flesh out my own understanding, and in case anyone actually looks at the GitHub repository of my solutions. And of course, just as review for myself in the future if I decide to come back to this problem. So I'm going to go ahead and run it, and then let's see where we're at. But again, this intuition is honestly not very simple, in my opinion. I'm still trying to grapple with it. I think I understand it. It makes sense based on positive and negative numbers, that if a number is positive, if a number is the maximum before, it can become a new minimum if we have a negative number, and vice versa. And also if a number is positive, it can become a new positive maximum. That's pretty straightforward. But I don't know. I just still haven't really grappled with the full solution yet. I just still don't really, it hasn't really clicked in my mind yet, and I hope that it does so at some point today. But in any case, I hope you learned something, and I'll see you for the next problem.